Hello everyone, welcome to my channel. In this series of videos on electronics, I will show you how to simulate circuits using Tinkercad. It is a tool from Autodesk and free to use by anyone. To begin with, head on to tinkercad.com and sign in or join now. If you require assistance in joining, please comment on the video and I will create a separate video for it. Since I already have an account, I am starting with signing in to my account. Once signed in, you will be greeted by the dashboard containing the designs already created. It has the options to create 3D models, circuits, and code blocks. Since our focus is on circuits, we will be using the Circuits panel. To start with, click on Create New Circuit. We will be creating a basic circuit to see it's working. And here on this screen you will see in the center, like the larger part is the workspace where we will be creating our circuits. Then on the right hand side is the component area where we have all the components we need. Then on the top panel we have some commands like rotation, delete, undo, redo, comment, hide and view, code, simulation, export and save. And on the top you can see the name is also there. Let's start with the name as today we are going to make the LED is LED circuit. Okay. So let us start with a simple LED. We will make a circuit in which we will be using a simple cell or a battery to switch on an LED. So we'll take an LED and you see the LED have two nodes, cathode and anode. Cathode is connected to the negative side and anode is connected to the positive side of the battery or cell. We'll start with a small cell of 3 volt, but cell of 3 volt. So I am connecting the positive. You see wherever you want to turn, you just click there and you can connect it to it. Okay, so since this is positive, I'll have to connect it to anode. This is done. We can even change the color of the wires so that we can identify which one is the positive wire and the negative wire. I generally take red for positive and black for negative. It's up to you, but that is the general convention. We take red for positive and black for negative. Once this is done, the next step is to light it up by starting simulation. But you see, when we run this simulation, it shows an error and it says the current through the LED is 61.9 milliamperes, while recommended maximum is 20 milliamperes. So you see, this is the advantage of using simulations. If this thing has happened with a physical circuit, we would have damaged one LED. So it's always better to do simulation first, then go for the physical circuits. The solution to this problem will be to increase the overall resistance of the circuit. To do that, we'll introduce a resistance in the circuit. First thing you will see is a resistance. So let's connect it. Connect the terminal. Since resistance is a non-polar device, it don't have any positive or negative, so you can connect in any orientation. The value of this resistance is 1 kilo ohm, which is too much, and still it will work. Let's see. You see, the bulb glows, but very little. So the ideal one for a red LED is somewhat in the range of 150 ohms. So let's put it 150 ohms. You see, LED bulb glows very well. So if you go for a physical circuit now with the same values as in the simulation, you will find that the LED works very well and very similar to the one shown here. That is the advantage of going for simulation before doing any physical circuit. Thank you for watching. Please feel free to write your responses in the comments. Bye bye. See you in our next video. Thank you.